This is a video from section 7.4. The directions say to evaluate the integral. And this section is on partial fraction decomposition. So that's the technique that I'm going to highlight in this section. So in example 1, we have the integral of x minus 12 over x squared minus 4x dx. And so what we're going to do is we're going to take x minus 12 over x squared minus 4x. And I'm going to factor the denominator into the following. So the numerator is x minus 12. The denominator is x times x minus 4. And so we're going to break apart this fraction. So we're going to get a over x. The degree is 1, so the numerator will be a constant for that x. And we're going to add b over x minus 4. So the LCD here is x times x minus 4. And so what we're going to do is multiply both sides by the LCD. So x minus 12 is a times x minus 4 plus bx. And I'm going to distribute the a in. So x minus 12 is ax minus 4a plus bx. And so x minus 12, I'm going to collect the x's together. So we're going to get, I should say it this way, we're going to collect the terms that contain the x together. So we get a plus b multiplied by x minus 4a. Now, this allows us to set up two equations. So notice a plus b is forced to be, a plus b is forced to be 1. Why? Because if a plus b is anything other than 1, these two expressions are not equal to each other. Okay? So here, a plus b has to be 1. And then negative 4a must be the same as negative 12. And so what that says is a equals 3. And if a equals 3, b must be negative 2 because 3 minus 2 is equal to 1. And so the integral of x minus 12 divided by x squared minus 4x dx is the integral of. Now, let's go back. A is equal to 3. So we get 3 over x. B is negative 2. So we get minus 2 over x minus 4 dx. And we can integrate that. And so this is equal to 3 natural log of the absolute value of x minus 2 natural log of the absolute value of x minus 4 plus c. And you want to talk to your instructor about how far you're wanting to simplify. Okay? But I'm going to leave the answer in this format right here. Okay? And that's example 1. Let's take a look at example 2. Suppose I had the integral of y over y plus 4 times 2y minus 1 dy. So y over y plus 4 times 2y minus 1 is equal to a over y plus 4 plus b divided by 2y minus 1. So once again, the LCD here is y plus 4 times 2y minus 1. So I'm going to multiply both sides by the LCD. And when I do, I get 1y is the same as a times 2y minus 1, right? So essentially I'm cross multiplying and adding, okay? So I get a times 2y minus 1 plus b times y plus 4. Just like this. So 1y is 2ay minus a plus by plus 4b. Now what we want to do is combine the terms that contain the y, and the constant terms are going to be combined. So 1y is 2a plus b quantity times y. And then I'm going to take negative a and then add 4b. Now, what that tells me is that 2a plus b has to equal 1. Because if 2a plus b is anything other than 1, this doesn't make any sense. These expressions can't be equal. And then we have negative a plus 4b equals 0 because there's no constant terms on the left-hand side. Now, what this says is a is equal to 4b. And I could do a substitution into the first equation. So 2 times, and in parentheses I have 4b, and then I'm going to add b, and I'm going to set it equal to 1. So 8b plus b equals 1, and so b is the same as 1 over 9. And then a is 4/9. And I'm in business because I broke apart this fraction into two other fractions that I know how to take the integral of, basically. So now a was 4/9. So I'm going to get the integral of 4/9 over y plus 4. So I get the integral of 4/9 over y plus 4 dy. And then I'm going to add 1/9 the integral of that over 2y minus 1. dy. And by the way, this is equal to, here, I'm going to say it this way. So this is equal to the integral of y over y plus 4 times 2y minus 1 dy. Okay? So let's note that. And so the integral of 4/9 over y plus 4 dy plus the integral of 1/9 over 2y minus 1 dy is equal to 4/9 times the integral of 1 over y plus 4 dy plus 1/9 times the integral of 1 over 2y minus 1 dy. And it's really straightforward from here. I'm done. So the answer here is 4/9 natural log of y plus 4 plus 1 over, now there's a coefficient of 2 in front of that y, and so I have to divide by 18. And you can see that with a u substitution. So it's 1 over 18 natural log of 2y minus 1, and then I'm just going to add that constant of integration. And again, I would talk to your instructor. How far do they want you to simplify these natural logs? But that would be appropriate to ask your instructor. Example 3. suppose I had the integral of 1 over x plus a times x plus b dx. So again, we're going to do partial fraction decomposition. So we're going to break this into a over x plus a plus b divided by x plus b. The LCD is x plus a times x plus b. So 1 is a times x plus a plus b times x plus b, where a and b, the lowercase a and b are constants. So 1 is ax plus a times little a plus bx plus b times little b, like so. Combine the terms that contain the x, and so we get a plus b times x plus a times lowercase a plus b times lowercase b. Now, what that tells me is a plus b has to be 0. So the coefficient of x has to be 0. So when we take the uppercase letters and add them, it's 0. And then when I take a times lowercase a and b times lowercase b and add those, I get 1. Now, remember, we want to solve for a and b, capital A and B. It's very important, okay? Now, let's come over here. So we get a plus b is 0. A times lowercase a plus b times lowercase b is equal to 1. What I would probably do is say a is equal to negative b. And then I'm going to make a substitution. And so negative b, a, plus capital B times lowercase b is equal to 1. Now, if I solve for b, I'm going to factor out a b and get b minus a, and I'm going to set that equal to 1. Now, for argument's sake, we want to assume a is not equal to b, because if a is b, we have a problem, okay? Now, capital B is equal to 1 over b minus a. And so, therefore, capital A is negative. It's the opposite of 1 over b minus a. Now we're in business. So, the integral of 1 over x plus a times x plus b dx. Okay, so we get, here, I'm going to move the constant out in front. So a is negative 1 over b minus a. So we get negative 1 over b minus a times the integral of 1 over x plus a dx plus 1 over b minus a times the integral of 1 over x plus b dx. So this is negative 1 over b minus a natural log of x plus a plus 1 over b minus a natural log of x plus b, and then I'm going to add c, my constant. And that would be how you do this example. So this was example 3, by the way. So we're going to take a look at example 4. So in this example, what if you have the same degree in the numerator as you do in the denominator? Now, notice how the degrees are the same. So you have to do a little bit of long division here, okay? Now, I'm going to teach you a trick on this. I hope we find it useful. Now, there's a t plus 1 in the denominator. Is there a way to rewrite -2 so I can break apart? I want to be able to break apart that fraction. And I want you to watch how I break this apart. The basic goal is I want to be able to rewrite -2. And the way I'm going to do that is I'm going to take 3t and then I'm going to add 3 and I'm going to subtract 5. And you might ask, why did I do that? Because if I take a look at the first two terms, I could factor out a 3 and then I have t plus 1, right? And that'll cancel out the bottom. And it's really slick. So watch what happens here. I didn't do anything wrong. I just took -2 and rewrote it as 3 minus 5. I'm just grouping the first two terms. Because here, I'm going to get 3t plus 3 divided by t plus 1. And I'm going to subtract 5 over t plus 1 dt. Okay? We could do another one like that if we need to. So here I get 3 times t plus 1 divided by 1 times t plus 1 minus 5 over t plus 1, this whole thing dt. But the t plus 1's cancel. And so you get the integral of 3 minus 5 over t plus 1 dt. And so this is 3t minus 5 natural log of t plus 1 plus c. And that's how you would do a problem like that. Let's take a look at example 5. Suppose I give you this one. Well, we'll go with the same theme. Suppose I had x squared over x minus 1 dx. Notice how the degree in the numerator is larger than the degree in the denominator? So the way this is going to work is I'm going to take x squared over x minus 1. And I'm going to do my version of long division. The way this is going to work is I'm going to subtract 1 and add 1. And the reason why is because I could do something with those first two terms. So I'm going to split off that fraction. So you have a goal of being able to cancel that x minus 1 in the denominator from the first fraction. That's exactly what happened in the other problem. So I'm going to write it this way. But remember that x squared minus 1 is x plus 1 times x minus 1 divided by x minus 1. And then I'm going to add 1 over x minus 1. This whole thing dx, x minus 1's cancel. So what I get is the integral of x plus 1 plus 1 over x minus 1 dx. Let's make sure. Yep. And so I'm done. So I get 1/2 x squared plus x plus natural log of the absolute value of x minus 1, and then I just add that constant at the end. And that's how you would integrate example 5. Let's take a look at example 6. Suppose I had this one. Suppose I had, we're going to do this one now. So the integral of 3x squared minus x plus 8 divided by x cubed plus 4x dx. So we're going to get a little bit harder, okay? Now, this is the integral of 3x squared minus x plus 8. If I factor that denominator, I get x times x squared plus 4. And I'm going to break this up with partial fractions. So 3x squared minus x plus 8 divided by x times x squared plus 4. So notice how one of the factors in the denominator is linear and the other one's quadratic. So I'm going to show you what the numerator has to look like for each. So when you break this apart, you get a over x. So there's still a constant on top when there's a linear in the bottom. But when you have a quadratic in the bottom, you need to have a linear on top, a linear numerator. And so it's going to look in this form, bx plus c. Now, that doesn't mean b can't be 0. It's very possible b can be 0, and that's fine. But that's not always going to be the case, so you have to account for that. Okay? And likewise, c can be 0. That's legal as well. So what ends up happening is you get 3x squared minus x plus 8. That's on the left side. On the right side, we're going to get a times x squared plus 4 plus x times bx plus c. And then don't forget, the LCD is going to be x times x squared plus 4. So what I basically did was multiply both sides by that LCD. And I'm going to distribute the a in, I'm going to distribute the x in. So we get 3x squared minus x plus 8 on the left side. On the right side, we get ax squared plus 4a plus bx squared plus cx. Yep. Okay. Now, 3x squared minus x plus 8 is a plus b times x squared plus cx plus 4a. So notice we have an equation for x squared, for x, and for the constants. Now, that says a plus b is forced to be 3. C is forced to be -1, and 4a is 8. But if 4a equals 8, what that says is a is 2. So notice I just took the constant on the left side and the constant on the right side and matched them. Now, if a is 2, we know b is 1. And I'm set. So I'm going to look at this. Okay, so we get the following. So we're going to get the integral of 3x squared minus x plus 8 divided by x cubed plus 4x dx. And I'm going to break it up as follows. I'm going to get a, which is 2. So I get 2 over x plus b is 1 and c is -1. So I'm going to get x minus 1 over x squared plus 4. So I get x minus 1 over x squared plus 4. And this is going to be with respect to x. Now, the classic way to attack that second term is to break off that fraction. So we're going to get 2 over x plus x over x squared plus 4 minus 1 over x squared plus 4 dx. And I'm done. So over here, it's 2 times natural log of the absolute value of x plus 1/2 natural log of x squared plus 4. And this third term is an arctan. So a is 2. right, for that third term. So I get 1 over 2 arctan of x over 2 plus c. And that's how that works. And you could check that third term real quick if you want. If I take the derivative of 1/2 arctan of x over 2, I get 1/2 times the quantity 1 over 1 plus x squared over 4 times a half, like so. Now, 1/2 times a half is a fourth, and if I distribute that 4 in, if I distribute the 4 in, I get 4 plus x squared, and that's what I want in the bottom. So it does indeed check out, and so this would be the final answer for example 6. I want to show you an example 7 here, but I want to show you the idea in this one. So suppose I give you the following. Suppose I have the integral of square root of 1 plus the square root of x, and I'm going to divide by x and then integrate that with respect to x. Here's how I would attack this. I would let u be equal to the square root of x. So u squared is x. Okay? And then 2u du is equal to dx. And so this ends up being the square root of 1 plus u, right? Because u is the square root of x. I'm going to divide by u squared. And then I'm going to multiply by 2u du. So that's just dx. Pull the 2 on the outside. And then I'm going to take the integral of square root of 1 plus u divided by u du. And then you might ask, well, what am I going to do with that? Well, from here, I'm going to let v, I'm going to make another substitution. I'm going to let v be the square root of 1 plus u. V squared is 1 plus u. So 2v dv is du. Now, so this is twice the integral of v. Now, u is v squared over minus 1. But I'm going to multiply by 2v dv. Okay? And so I'm going to pull that 4. I'm going to make that 4, right? And then I get v squared over v squared minus 1 dv. And this here can be done a couple ways. It could be trigonometric substitution, or it could be partial fractions. And in another video, we're going to continue. I'm going to subtract and add 1. And I'm going to break this apart into 4 times the integral of 1 plus 1 over v squared minus 1 dv. And that'll conclude this video for section 7.4, where we worked on partial fraction decomposition. So this problem will be continued in another video. Thank you.